Hi everyone. Again, it's a beautiful day to learn. Let's continue our discussions on basic IP addressing. When you configure your computer, you will be asked with several parameters as input to connect your computer to a network. Among the parameters asked are IP address, subnet mask, default gateway, and several DNS servers. In this discussion, we will focus primarily on the two numbers, the IP address and the subnet mask, which basically represents your computer's IP address and the network to which it belongs to. Remember that in a classful IP addressing, we have three classes, A, B, and C, and each class has already a predefined subnet mask for it. You just have to make the network octet 255. So in the case of class A, the subnet mask is always 255.0.0.0. And for class B, since you have two octets representing the network, you have 255.255.0.0. And the same thing with your class C, with two networks associated with it. So therefore, if you have an example IP 192.168.10.10 as shown here, this is classified as class C, the subnet mask is automatically assigned with 255.255.255. And if you have a 10.5.1.1, the class A, the subnet mask is 255.0.0. Let's talk about network and broadcast address. When you have a large network and you would like to divide them into smaller networks, we will call here as a subnet. Like in this example, we have the three colors representing different subnets A, B, and C. What is the address that you will be assigning to your computer and to which network it belongs to? So you should be able to figure out how to do that. So let's have the five questions on my head. What is the network address? What is the broadcast address? How many hosts can be placed in one network? And what is the first usable IP as well as the last usable IP? Be able to compute that given some values like this one. So, example. Assuming one of the computers is assigned already an IP address 192.168.10.10. And as we have seen in the previous slide, it's a class C, so you have 255.255.255.0 as its subnet mask. Now, let's compute first for what is the network address. Meaning, all the computers stationed in that subnet A, they should have the same network address. To get the network address is very simple. So what we are going to do is to identify the network part and the host part. So in this case, because this is class this is class C, so the network part will be the first three octets, and the host part is the last octet as represented there with the 0 in orange. So when you convert that to binary, you will get this equivalent. 192 in the black is 1.110000000, and 168, which is in red, is 10101000, and the violet 110 is 1010, and 10 is 1010. Remember, you have to put it as an 8-bit representation. So what you are going to do if you want to get the network address is to simply make all the host bits 0. So in this case, the host bits is this one. Right? So this is the host bits. We will just have to convert all of them to 0, and then you will be arriving at this network address. Okay, so this result here, when you translate it back to decimal notation, you will get 192.168.10.0. So, simply put, what you are going to do is to simply copy everything under the 255, 255, the 255. So those three columns, those three octets, you copy them as it is, and then the remaining octet, you just have to turn it into 0. But mathematically, the solution is like this. So get used to doing it like this, because in the higher IP addressing topics that we will have, you will be using this same mechanism to get the IP address or the broadcast address, network address, and all that is required. So we have solved the network address. That means every computer in this blue subnet A will have a network address of 192.168.10.0. That basically identifies to which network you belong. So the next question is, what is the broadcast? By the way, what is a broadcast address? If one of these computers would like to send a message to all of the computers in that particular subnetwork, there should be some address to contact with. Something like you press a button in your phone, dial that number, and then voila, you have a group call. Have communication with all the other friends that you have in your contacts. So similarly, for every subnetwork, there is a network address and a broadcast address for purposes of broadcasting, such as finding DHCP address. Okay, so let's move on. The broadcast address is computed similar to the network address. The only difference is, instead of making it the host bits as 0, we will have to make them as 1. So in this example, we'll use the same example that we have previously. We converted them to binary, and then we already have identified that the last bit or the last octet is the host bits, right? Because this is a class C network. So we know that that is the host bits. And we will convert all of those bits into 1. And when it's translated to an IP address or a decimal format of the IP address, you will get 192.168.10.55. Simple. So therefore, in this network, the network address is 10.0 and the broadcast address is 10.255. So the next question is, well, how many computers could I put in that network? For that subnet A, how many computers all in all I could assign a usable IP? Oh. To get the number of hosts is, you simply get the number of bits remaining for that host. So we know that it's 8 bits remaining for the last octet. So that is 2 raised to 8, that will give you 256, minus, we have to remove the 2 addresses, which is the network and the broadcast, that is the -2. Those are not part of the usable IP. Therefore, the total number of IP addresses that you could assign to host will be 254 all in all, right? And anything in between the network address, which is that 0 and that 255, anything in between that, those are the usable IP. The first usable IP is 10.1, and the last usable IP is 10.154. All in all, you get 254 computers that you could assign an IP address for that sub network. Get it? Let's take a look at another example. This is a Class C network address. I'm sorry. This is a Class C IP address 10.5.8.7. We have seen again in the previous slide that the default subnet mask for such a class is 255.0.0.0. So as we have seen with the procedure, you just have to copy the network address and make the host bits as 0. So they copy the first octet only, right? We practice converting the figures. I did not have to convert the first octet because I am very sure I just have to copy that one. Okay. So 10.5.8.7 is the same as this binary number. And then as a rule for network, you have to convert them to 0. So the network address is 10.0.0. And similarly, for the broadcast address, you just have to convert all the remaining host bits into 1, which makes your network or broadcast address as 10.255.255.255. Okay, so can you figure out already how many IP addresses assigned in that network? To compute for the number of hosts, the same procedure, 2 raised to 24. So why 24? Because you have 3 octets, 8 plus 8 plus 8, that's 24, minus 2. What's the minus 2 again? That represents your network and broadcast address. They are not part of the usable IP. That means you cannot assign an IP address 10.0.0.0 to any computer, nor you can assign 10.255.255.255 to any computer. Those are not usable IP because they have special purposes. All right? So, given that number, you will have 16,777,216 minus 2 usable IP addresses. The first usable IP is 10.0.0.1, and the last is it's the broadcast address just minus 1, so that is 254. So that's a lot of IP addresses that you could find for. Right, so that's it for network and broadcast address. And I'll see you again in the next videos.